Hello, my name is Ishwar. My metric number is MA21044. Today I'm going to present about introduction. So we are be going to talk about sustainable energy management, and our title is UN SDG Goal 7, affordable and clean energy. So Goal 7 is about ensuring access to clean and affordable energy, which is key to the development of agriculture, businesses, communications, education, healthcare, and transportation. The lack of access to energy hinders economics and human development. Okay, introduction. For introduction, the energy management is today's keys to helping businesses increase energy efficiency, reduce greenhouse gas emissions, and reduce energy costs. The techniques, process, and initiatives that encourage more efficient energy use are referred to energy management. Second is controlling and maximizing energy consumption is another aspect of energy management. It is must made up smaller process that individually control how much energy is used during a certain time frame. Okay. Secondly is case study. For case study, we're going to present about Federal Mogul Indian Limited Bahadurak Patiala Punjab, which is manufacture over 9.5 million pistons annually, was the subject of a case study. The 1954 construction of foundry result in a cover area of around 50,144 square meters. The foundry under consideration is used to cast piston, which is size ranging from 30 mm to 300 mm, and is available to produce 13 million pistons annually. To lower the price of energy usage in the production of piston, the firm intends to start a Six Sigma effort. To lower the price of energy usage, it is intended to decrease the proportion of scrap piston generate from 22% to 10%. RM total RM 90,500 ringgit will be saved annually in an endeavor to achieve effective sustainable energy management. Thank you.
Assalamualaikum. My name is Muhammad Fidaus. My metric number is MA21026, and today I will present about the under the title of Define Phase, which is the project scope. So first of all, our project name is Sustainable Energy Management, and our business case is to reduce the cost energy consumed to manufacture piston by 30% and will increase the profit. Our project scope focuses on reducing the cost of energy consumption through the AIC approach. Our problem statement is in the past 6 months, cost energy consumed to manufacture piston has been increasing. The manufacturing cost is also higher. So our target statement is to reduce the cost of energy consumed to manufacture piston by 30% and save approximately 90,500 per annum. And our estimated financial benefit is approximately 90,500 saving from energy consumed in piston manufacturing per year.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Malik bin Azmi. My metric number is MA22090. So today I'm going to present an overview of our key metric focusing on CTQ3. Our goal is to identify and address the customer most significant need through their feedback and align our project objective accordingly. So let's start with the customer need. Our customer demand high quality and affordable auto part. To meet this need effectively, we have identified several key drivers. These key drivers are essential elements derived from the customer demand. They include resource allocation, productivity level, energy management, and innovation, and also improvement. Now, let's explore the CTQ requirement that stem from the driver. Our CTQ requirement are the actionable step we need to take to address the customer needs effectively. We have identified 3 significant requirements based on our driver. The first one, in terms of energy efficiency, we aim to achieve a 30% annual reduction in energy usage during piston manufacturing. Second one is in terms of production rate. Our goal is to increase production by 20% annually, leading to overall profit growth. And the third one is financial performance. We expect a 20% annual increase in profit through improved productivity and resource allocation. The fourth one is sustainability. Our focus is on reducing carbon emission and overall energy consumption by 30% to contribute to a greener environment. For the problem statement, I divide the problem statement into some important point to help us in understanding the problem statement. In the past 6 months, the non-ferrous foundry at Federal Mogul India Limited has encountered significant challenges. The company research and development R&D team expenditure has been remarkably low, averaging less than 0.6% of the turnover, which is below the global average. The second point is problem factor. The foundry is also struggling with low productivity level and high scrap rate, capacity waste, and energy consumption. These challenges are considerably higher compared to other countries. Additionally, poor coal quality, inadequate power supply, and rising energy costs worsen the situation. The third point is proposed solution. To address this issue, the foundry plan to implement a Six Sigma initiative. The main goal is to reduce the scrap percentage of piston produced from around 22% to 10%. This improvement will result in reduced energy consumption and improved operationally efficiency. So in conclusion, Federal Mogul India Limited non-ferrous foundry operation face significant challenges related to R&D expenditure, productivity, and energy management. The proposed Six Sigma initiative, focusing on reducing scrap and enhancing efficiency, aims to tackle this issue head-on. Thank you. The major phase is the crucial second step in our improvement journey after defining the problem. This phase involves a comprehensive analysis of our measurement system, capability studies, and identifying performance gaps related to the problem. Let's explore the key point together. The first key point is purpose. The measure phase serves 3 primary purposes. First, we truly analyze our measurement system to ensure accuracy and reliability. Second, we conduct capability studies to assess how well our processes are performing. And finally, we identify performance gaps directly related to the problem we address. Tool use. To achieve this objective, we utilize several powerful tools during the measure phase. This tool includes the Sigma calculator, CPK studies, Pareto chart, FMEA table, cost and effect metric, R&R studies, bias checking stability studies. That's all. Each tool plays a crucial role in helping us gather accurate data, assess process capability, identify critical area for improvement, and evaluate stability and reliability of our measurement system. The tools we use during the measure phase are instrumental in ensuring the success of our improvement effort. Accurate data collection is crucial for making informed decisions. Assessing process capability help us understanding where improvement are needed, identifying critical improvement areas, allow us to prioritize our action effectively, and evaluating the stability and reliability of our measurement system ensure consistent and trustworthy data over time. So, in conclusion, the measure first play an important role in our improvement journey by truly analyzing our measurement system, conducting capability studies, and utilizing powerful tools. We gain valuable insight that guide our subsequent action. Let's leverage the knowledge gained during the measure phase to make informed decision and propel our organization towards improvement.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azul Hakim Bizanri. My IAM metric number is MA21130. So I will explain the measure pace is the SIPOP. So the first element in the SIPOP is the suppliers. Suppliers is the entity or individual who provide the necessary input. So we got the supply is from the ASA Chemical, Hunter Foundry Machinery Corporation, and so on. The next element is the input. The input we got is we have is the manpower, raw material melting machine tools, shoe casting, power, dust, hook cut, consumable, and packing material. So for the important in the cycle is the process. So the first process we got is we have to choose the raw material. We expect the material and we do a melting process. After that, we high a pressure die casting. We do a shoe casting. After that, we have to CNC machining. We finish the process, and we expect again. We got the product with the piston we want to do, and we packing. So the next elements, we got the output. For the output is from the input, and for the process, that is the quality piston manufacturing quantity or on time. And the last element is the customer. The customer we got is from the Seki Corporation, which is the automotive company from Japan. So that's all for me. Thank you. Assalamualaikum warahmatullahi wabarakatuh. I will continue again with the cause and effect. So what the cause and effect? The effect is to identify the root cause of a problem or defect in a process. So after we do a cause and effect in Excel, the total or math score we got is 252. So to we also use the top party method to choose a key process input variable or KPIV. So to do a third quarter, which is we have to math score times with a 25% and we get a 93. So the selection range, the math score minus with the quarter, which is we got a 189. To choose the KPIB, we got the selection range between 189 and 259. 52. We are what we got from the selection range is high pressure casting, shoe casting, CNC machining, and receiving material. For the we have to prioritize uh, this this process input. So this for input will be complete before moving on to FMEA, which is failure mode and effect analysis. Thank you for me.
So we'll continue the next part, which is FMEA, failure mode and if analysis. In this, FMEA is a structural approach to identify possible failure in a process or product. So in the FMEA table, we have process and input. What input is under investigation. Next is potential failure mode. What way does the key input can go wrong? Potential failure effect. The impact to the company or customer when the key input go wrong. The severity is how serious the effect of this key input to the company or customer. Potential cost. what caused the input to go wrong? Occurrence is a likelihood for the effect for the this input to go wrong. Current control, what is existing control to avoid this key input to go wrong? And detection, how quickly can we detect the failure can be happen when the failure happen? And the RPN is a product of severity multiplied by occurrence and multiplied by detection. So the next part is action recommended. What the what are the action for reducing the occurrence of the cause or improving detection? Next is respond. Who responsible to 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 making sure the action are complete? Action taken. What are the action taken by the person that responsible, and the new severity, occurrence detection, and RPM. So this response action taken and the severity occurrence detection RPM is optional to be filled up in this table. So the process input that will fill up in this table is the process input that we fill up in this table we get from the cause and effect, the top four from the cause and effect. So the input that we'll get from the cause and effect is high pressure die casting, short lasting, CNC machining, and raw material receiving. So for the first part is high pressure die casting. So the way that this input can go wrong is the press does not function properly. And what the impact to the company or customer when this input go wrong is the production will stop. The severity, how serious this input when it go wrong is it, and the potential cost for this input can go wrong is maybe mechanical or electrical failure. And occurrence, how easily can we detect? No, occurrence is the likelihood or frequency for this input to go wrong, and the current control to solve this problem is daily inspection in mechanical and electrical component. The detection will be 2 and the RPM will be 32, and the current control are effective for the action recommended. So for short blasting, one of the key input to for this key input to go wrong is blast nozzle does not receive enough air or volume. So when this key input go wrong, the production will stop. The severity will be 8, and how what the cause for this input to go wrong is the nozzle wear, nozzle orifice grow larger, and the occurrence will be 2. So to solve this problem, we need to replace the nozzle. The detection will be 4 and RPM will be 64. So the action recommended to reduce. So what is the action for reducing occurrence? Currently is the effective for current control is currently effective. So next is CNC machining. One of the way the key input can go wrong is incorrect program. So when the when the operator key in the incorrect program, the production will stop. The severity will be 8, and the input will be go wrong is the lack of understanding in using CNC machining. The close will be 2, and the current control to solve this problem is new operator must be trained adequately. The detection will be 3 and the RPM will be 48. Current control are effective. The lastly is raw material receiving. One of the input, one cause that this input can go wrong is wrong raw material received. The production will be slowed down. The severity is 7. The cause of this failure to happen is material not labeled, the raw material not labeled correctly. Occurrence will be 2 and proceed. So the way to solve this problem is we should define all procedure. The detection before and RPM will be 36. The current control is effective. The next part is benchmarking. In the benchmarking, we have normality test and process capability. In normality test, we need to do descriptive statistic, histogram, and chi-square test. So, in descriptive statistic, we need to find the mode, median, and mean from our data. And next, we need to do the histogram, where we key in all our data, the Excel, where it will automatically show the diagram of our histogram. In our case, our histogram appear to show a bell curve-like shape. This is the early sign that show our data is normal. To confirm that our data is normal, we need to do the chi-square test, where the null hypothesis H naught is the data is normal, and the H1 is the data is normal. So when we do all the calculation, we get the p-value is 0.9954, which is more than 0.05. This show that our data is normal. Next, next part is process capability, where it is the test is the way to is the process to show that our data is process capable. So the first part we need to do is to do run chart, where we need to find whether our data is in common cost variation or in special cost variation. So common cost variation is the natural or expected variation in a process, while special cost variation is an unexpected variation that result from unusual occurrence. So in our case, our data is in common cost, where it is the expected variation in a process. Next part, we need to find the CP, CPK, and Z. When we do all the calculation, our CP is our CP and CPK is more than 1, and our Z is more than 2. So this show that our data is process capable. The last part is we need to find the sigma value. So we just key in all the data for 6 month data, and we will get our sigma value.
Assalamualaikum, my name is Muhammad Firdaus. My metric number is MA21026, and today I will present about the conclusion of our project. So at the end of the study, we can conclude that Six Sigma is very effective for waste reduction, production efficiency, and sustainable energy conservation in foundry sector. Next, organizations should integrate Six Sigma into their core business operation. And lastly, Indian firms are implementing Six Sigma with potential for future growth in zero defect foundries and energy saving. So that's all.